slope and for derivative, which are the same thing really, what's the equation or the formula for the slope of the tangent line at C? Yes. Limit starts with the limit as what? As h approaches 0, because h, think of h as that's the horizontal distance between this point and some other whatever point on the curve. And we want to take that horizontal distance between the points and squeeze it until it disappears. So we will always want h to approach 0. And then it's the limit of what? Big mess. All over h. So f of c plus h minus f of c all over h. And c is just a number. C comma f of c is some point on the curve. It could be 2 comma 7. It could be 3 comma 1. It could be 0 comma 0. It's some point on the curve that we want our line to be tangent to the curve at. Now, compare that to the derivative of the function at any value x, and what does that limit look like? Okay, that is h approaches 0. We're off to a good start. Of what? Okay. So they're the same thing, except this is at a particular point, and this is at any old point with any old x. X is just a variable. So the result of this top thing is a number that you get for your slope, and the result of this bottom thing will always be like, will usually be an equation that you can then use to find your slope at any point. So this is more powerful, and this is going to be what we use more of the time. But this is what we started with yesterday, so let's kind of pick up where we left off. Over here. So yesterday I had this up on the board, and some of you got to it and some of you didn't. A handful of you actually were able to solve all the way through to the end and find the slope and then write the equation of the tangent line. Let's work through it together, and then I'll have you guys do 32 and 28 on either side of the middle board on your own. I'll give you a chance to practice this while I walk around and check on you. And then we'll come back and look at the stuff in the middle board all together. Also, just a reminder, I'm out tomorrow. Tomorrow you'll have the whole block to work with each other or by yourself if you hate your classmates. I don't care. And you'll be working on homeworks 2.1a and 2.1b. Those are posted on Schoology. And 2.1a is a lot of what we were doing yesterday, and 2.1b is more of that plus a little bit of the stuff from the middle board. So it'll be taking what we're doing the last 2 days and giving you guys a chance to really hammer it and practice it. The textbooks are in the back if you need a textbook and you don't want to have a hard copy that's on Schoology. So, first off, if we want to find the slope of the tangent line at this point, we're doing which of those formulas? Actually, we could always do the bottom one. I was saying we're at a particular point, so let's use the top one, because that's kind of what we were doing yesterday. So we're going to say our slope m, we could also call that f prime of c. What's our c value here? 5. And that's going to equal the limit as h approaches 0. And now we've got to do our f of c plus h. So what is f of c plus h going to look like with this function and this c value? Beautiful. So square root, because it's a square root function, x turns into 5 plus h, and then you're minus 1 from that. And then that whole thing is f of 5 plus h. Then you want to subtract f of 5. So when you minus f of 5, what does that look like? Square root of 4. That's square root of 5 minus 1. If you want to make it really clear, you can plug in 5 for x and say that's the square root of 5 minus 1. So that's your setup. From here, we got to clean this up as well as we can. What's going to be our first step in cleaning up that limit? So what can we do with this first square root? Yeah, subtract the 5 and the 1, so we'll get 4 plus h. And with the second square root, what can we get from that? 2. So 5 minus 1 is 4, square root of 4 is 2. And then this is where you reach back in your memory to limits and say, how do we take a limit like this? Like if we plugged in 0 for h, we're going to get 0 over 0. Well, we don't like that. So what do we do now to deal with the radical? You rationalize it. So go ahead and rationalize it. What's the conjugate of the numerator going to be? Root 4 plus h plus 2. Notice, by the way, I'm not saying, oh, square root of 4, I can do that. Pull out a 2 and call it 2 root h. If this was 4 times h, cool, go ahead and do that. Because it's 4 plus h, or if you had a 4 minus h, all of that is stuck in there together. You can't simplify this individual square root because it's multiple terms in there. So you have to rationalize your numerator. When we do that, what happens to our numerator? Now, what do we have up top? 4 plus h minus 4. And in the denominator, do we do anything with these things? No, we just kind of sit them next to each other. We have an h factor, and then we have an ugly factor, root 4 plus h plus 2. And now, we can start to finally get somewhere with simplifying this fraction, because what happens over here? Cancel out the 4's. This 4 minus 4 is 0. And then, cancel out the h's. And we've got the limit of 1 over our conjugate, root 4 plus h plus 2. And now we can finally take 0, plug it in for h, and what do we get out? 1/4. All of that is to say, there's a slope of the tangent line and the slope of the curve at this point. So we can say m equals 1/4. Ta-da! And now we can take that slope and do stuff with it. In particular here, what we want to do with our slope is write the equation of a tangent line. Now you might say, oh, now we got to do more? Well, if you reach back in your memory to chapter P when we were writing equations of tangent lines or any line, this can be really quick if you use point-slope form. So you have a point, the point of tangency. You have your slope, put them together. So we can say over here, all right, our tangent line will have this equation. What's y minus y1 for our point-slope form? Y minus 2. So y minus y1 is just y minus the y coordinate. And then slope is m. And that multiplies x minus x1. X minus the x coordinate of the point. Done. So once you've got your slope, doing something with it, if that's just write the equation or the tangent line, I recommend point-slope form because you have your slope. You'll, for right now, be given the point of tangency, the whole thing, and you can put them together in your tangent line. So tangent line, use given point and the slope you found. Any questions with that? And if the prompt doesn't specify, oh, you need slope-intercept form for the tangent line, it says write an equation of the tangent line. Any old equation will do for that line, any form. So just leave it like that. That's the least amount of work. So this is an example where you have to rationalize your numerator using your conjugate to be able to simplify and take the limit. Here, because your function is a fraction, this is going to create a complex fraction where you have to kind of like multiply by fancy 1. And over there, you see you have an x cubed, so you're going to have something getting cubed that you got to distribute out. So right now, try 32 and try 28 on your own. Talk with each other as you get stuck or run into an issue. I'll come around and check on what you're doing. I'm going to take attendance first. And thank you. And Prince, for number 28 that you can't see right now, the function is f of x equals x cubed plus 1. And we want to find the slope of tangent line to f of x at the point 1, 2. And Who's that? Andres, thank you. So, no Andres. Rusty is here. Guys here. That's Prince. He's on a computer. Cool. Oh, would it help to have the answer down here for each of these so you know if you're getting stuff right? All right. It says, I can't guarantee that I get to every single one of you when there's 30 of you. So this thing, when you get all done, the slope should be -1. And for this one, the slope should be Is everybody here right now? Makes walking up and down the road difficult because then if I want to look at these people's work, I'm trying to like look over their elbow. All right, what's up, Marlo? Sato, good. Thank you. Cool. Let's see. Multiply this numerator on here, whole fraction. Do that. That's 1 minus 1 all over h1 equals 1. So because you didn't multiply that to the h down here, you didn't really multiply by the piece. That's a good start. And then, all right, when we multiply here, h plus 1 times the first fraction gives you 1. H plus 1 times the second piece gives you a negative 1 of h plus 1. So the numerator there is backwards. Otherwise, all right. So C value is 0. It should be 0 plus h. 0 plus 1. So you're doing it 0.1 times. Ones. Now, just be careful when you multiply. This negative 1 multiplying the whole thing. Negative. Right. Otherwise, so when you no. So oh, you're canceling out this h and that h. That's what's going on. Yeah. Okay. Taking the time to actually distribute the negative and simplify the numerator is worth it. Oh, okay. Because you're missing a negative on that. Yeah. All right. Cool. So now multiply by also.
Oh, that was the first one, and then I did that. But yeah, that's you're using the wrong food. I'm really sure. Oh, okay. What exactly? This is one
Yeah, so like X, let's do that example. Here's 2 times X plus 8. So set up for number 3. The function is easier, but the setup with it then is more difficult.
All right, I'm seeing several people with the setup over here. 32 is looking pretty good on the whole. Couple mistakes with being careless with distribution to a negative. But other than that, mostly I'm liking what I'm seeing on 32. On 28, when we set this up, say f of c plus h minus f of c all over h, we're running into some issues with setting that part up. So this is going to be c is 1. So when we go into the function, what's f of 1 plus h going to look like? Yeah. So it's not going to be, and this is maybe where starting here with the formula before you jump into it is helpful. I always think in the AP, graders agree that when you're going to use a formula, it's important that you write down the formula before you then start using it. And I think that's just kind of helpful to have everything organized before you start. So f of 1 plus h doesn't mean you plug in 1 and then tack a plus h on the end. It means this whole thing goes in for x. So instead of an x getting cubed, now it's that thing getting cubed plus 1. So that's f of 1 plus h here. And then you subtract f of 1. F of 1 is going to be just 1 cubed plus 1, where you just plug 1 in for x. If you wanted to do things in terms of x and have a function like f prime of x equals an equation and then plug 1 in down there, then same thing, and this is x plus h and x plus h. And then you got to be careful with how you distribute this 1 plus h all cubed out. That kind of goes back to yesterday's formula. So I'll let you guys take it over from here. If you were struggling with getting set up properly, so go back, check your work, make sure you had it set up properly. If it's not set up like this, or if you're doing things in terms of x, it should look like this. Now it's distribute everything out on top, combine all your like terms, and then divide out an h from everybody. Because once you combine all your like terms in the numerator, all the surviving terms should have an h involved. All right, so carry on. Yeah, it was poor guy. One of them I taught 2 years ago. Yeah, it's a consumer math class.
remind me I'm subtracting all of these terms, not just the first term. So you have a minus 1 and a plus 1 should be minus 1. Order operations. So you need to combine in the numerator and then combine. Alright, so like everything in the numerator is effectively in parentheses. So you got to put parentheses to 5. You can have to get it all at once. And we'll say that happened first. Okay, so then have it set up correctly. Just be careful 1 plus 8 plus 2. Which is what that here right now. Like my children or my well, my oldest is like 6. So probably eventually. At the moment, her math work is to read a chapter of her math textbook because for some reason back right alongside of the math she needs to form a story about a guy named Fred. I'm not sure I like listening stuff about it, but yeah, Fred series. You like Fred? It is weird. He is a 6-year-old genius who teaches at university. And there's a whole series of books starting from like kindergarten math up through like calculus. It's used a lot for like so my daughter who's going to go home school co-op, it's like private school before she goes in twice a week but has like school and the other 3 days a week. So only I would say yeah, sure. But then the last 2 years of all the like, I was like having my 6-year-old in school. So we started to there and like yeah. These ones are all the titles of the elementary school ones are like apples, then something with beads is alphabetical. So like cats. No, I'd like it back. All right, so back up to here because I want to get to at least one of those. Does anybody want to see this worked out to the end? No? Yes? Okay, that's fine. So doing this out, remember 1 plus h cubed means 1 plus h times 1 plus h times 1 plus h. And you can go to town distributing that or do the Pascal's triangle thing. If you're going to go to town distributing, multiply these two together, see what you get, and then whatever that is, multiply to the third of the 1 plus h's and distribute again. In the end, what you get from that is going to be 1 plus 3h plus 3h squared plus h cubed. And then you have a plus 1, and then you have a minus 1, and then you have another minus 1. Make sure you distribute this minus to both of these, or say, hey, that's 2, and then subtract 2. And then you have to combine like terms across the numerators. You have 1 plus 1 minus 1 minus 1. They all cancel. And you're left with 3h plus 3h squared plus h cubed all over h. So now everybody divides by h, and you have 3 plus 3h plus h squared. And you can finally take your limit and let these h's disappear and go to 0, and you're left with 3. So, ta-da, what I said. Then, once you got your slope, you can write your tangent line equation and say, all right, my tangent line is y minus the y coordinate, y minus 2, equals your slope, 3, times x minus the x coordinate, is x minus 1, and that's fine. So I ran through that really fast. Is there any like particular detail anybody wants me to go into in more with more attention? Okay. So on the middle board, what we're doing here
is we're saying, let's just find the derivative. So instead of finding the slope of the tangent line or finding the slope of the curve at this one point, we're saying find the derivative, and then you can use that derivative to find the slope anywhere along the curve. So this is more powerful, and this is what I would recommend you do most of the time, actually. So you want to look at 3 or 4? 3? All right, let's look at 3. So find the derivative. Now you're using the bottom formula over there. And it effectively works the same way. The only difference is instead of now having a number for C, now we just call it X. And then we work through the same process as we did before. So this would be the limit as H approaches 0 of, making a hash of this, F of X plus H minus F of X all over H. And then setup, you got to be really careful. You want to call that X is H. So what is the F of X plus H part going to be? X plus H cubed plus 2 times X plus H. So what's nasty about this is you got 2 different X's in your function. All the X's get turned into X plus H. And the temptation, again, is going to say, oh, I'm going to make that X cubed plus 2X plus H. Or a temptation is going to be so focused in on the X cubed that you forget to turn the 2X into a 2 quantity X plus H. So each individual X in the function, each of them turns into X plus H. And then whatever's happening to the X now instead happens to the entire X plus H. So this first X was getting cubed, so now it's an X plus H getting cubed. This second X was getting times by 2, so now it's an X plus H getting times by 2. So that's that whole first thing in the brackets is F of X plus H, and then you subtract F of X, and what's my F of X? Yeah, just the original function. So F of X that you subtract is just, hey, what do you see here? Boom. And then it's all over H. And then from here, it's very similar to what we just did, except with X's instead of 1s. You now go crazy distributing this out, so you have to distribute out X plus H all cubed, the way I did over there with 1 plus H all cubed. You got to distribute the 2 through the X plus H. You got to distribute this minus sign through the X cubed plus 2X. You got to combine all your like terms, and then you can cancel out an H and take your limit. And now you'll have an equation that is your derivative. When you do all that, you get down to the end, and your derivative is called F prime of X. And it would be 3x squared plus 2. And I would like to go through that all, but we're down to a minute, so we don't have time. So again, you guys have the whole block tomorrow to work on your 2.1a and 2.1b assignments. We're not going to work on them at night to get a jump on it, and you can work together tomorrow or by yourself, whatever suits you. And I expect you to do your job while I'm not here, knowing that you know what your job is. I have no clue who the sub is going to be. I didn't think to line that up ahead of time. So the sub is going to be whoever you luck into. Whoever it is, I don't care who it is, I expect you to cooperate with the person, no matter how unpleasant that person may be.
There are 2 substitutes here. There's Mr. Khan, and then there's Miss